So problem 21 is one of these problems. Again, none of these really have to do much with chemistry, but what it teaches us is sometimes the answer that we might need to find is something that's a relationship property, like density, that really has two units with it. It's a mass to volume relationship. So if we can have a way to find the numerator and then a separate way to find the denominator, we can put those two pieces of information together to solve the problem. So let's see if we can pick this problem apart and see how we're going to work through that. So a picture to help us think about this, we've got a steel ball bearing. So I'm going to draw a little sphere here to represent our ball bearing. It has a circumference, so again, that's the distance all the way around, of 32.5 millimeters. And it also tells us that it weighs 4.20 grams. So we'd like to know, the question is asking, what's the density of this steel ball bearing in grams per centimeter? So we want to know density, which is again mass over volume, and they want to have that density, they want the mass in grams and the volume in cubic centimeters. Well, the good news is they actually already gave us the mass of the ball. So we can just put that right in the numerator. So our question becomes, do we have a mechanism of converting the circumference of this ball, which they give to us as 32.5 millimeters, do we have a way of converting that to something that has units of cubic centimeters? And they do give us other pieces of information with this problem that we're going to need to use. We'll show them here with our roadmap. These are pieces of information I would not expect you to know, but know how to use. So let's talk about this. Again, they gave us circumference. They gave us circumference in units of millimeters. Well, they gave us an equation here, right? We've got circumference here that they talk about. They give us a circumference equation that'll allow us to walk from circumference to radius. So we'll still have radius in millimeters, but we're going to take the fact that circumference equals 2 pi r, and we can take this equation and we can solve for r. So using just some simple algebra here, r is going to be equal to the circumference divided by 2 pi. So algebra is going to be a really important math skill for us to be able to utilize here. So if that's something that you need to practice some more, keep practicing problems. If you need some basic algebra problems, let me know and I can sort of get you an algebra worksheet to kind of work on solving for different variables. So that second equation there is going to allow us to walk between circumference and radius. And then they also give us that the volume of a sphere can be calculated by 4/3 pi r cubed. And since we have the radius, then we can walk to volume. Now keep in mind that since our radius is in millimeters, we're now going to have the volume in millimeters cubed. So in this case, it's not really unit conversion that's going through these first two steps. It's actually an equation that we're using, and that's a new thing, but that's not uncommon. So again, let's kind of highlight things that are new here in red. Sometimes our walk between units might be using an equation. But once we get to the volume in millimeters, then we're going to have our more traditional unit conversion. And in this case, I know that 1 centimeter is going to be equal to 10 millimeters. And maybe you might be thinking, all right, I'm going to go from centimeters to meters and then meters to millimeters. But I'm going to give you again some practical examples to think about when you think about sizes of things. Remember our sugar cube analogy. A sugar cube is about 1 centimeter on each side. It's about 1 milliliter in volume, and it's about 1 gram in weight. So that's kind of one of those little things to put in perspective. When you're thinking about millimeters, I want you to think about the thickness of a dime. So if I were to stack 10 dimes on one another, that would get us to be about a centimeter. Okay, so just a little perspective here. Make sure that we get these in the right order so that a sugar cube is 10 dimes stacked, not the other way around. Very common mistake that students can make is not having the right value with the right unit, particularly for these prefix conversions. Okay, so sort of have your logic hat on there. Once we do this, we're going to get 2 centimeters cubed. That gives us the piece of information that we then need to put in to solve our density relationship here. All right, so let's go ahead and put all of our pieces in now that we've got our roadmap. So we know that we're going to get to radius by taking, so again, to solve for radius, we're going to take the circumference and divide by 2 pi. You should make sure that you have a pi function on your calculator. So 32.5 millimeters divided by 2 pi equals 5.17254 millimeters. And again, that's going to be our radius. We can take this and 4/3 times pi times this 5.17254 millimeters. I'm going to cube that, and that's going to get me to 579.6958 millimeters cubed, right? So to kind of map what we've done, circumference here, we use this equation, solving for radius, to get us to what our radius is. Notice that I've left a lot of significant digits here. Don't round yet, don't round too soon. Once I know my radius, I can use my volume equation here, that's what I've done here, to get my volume in cubic millimeters. And now the last thing is to do what really equates to unit conversion here. And I'm going to take 579.6958 millimeters cubed. I want millimeters to go away, centimeters to be on top. I know that 1 sugar cube is the equivalent of about 10 dimes stacked. So my 10 goes with my millimeter, my 1 goes with my centimeter. As you're doing these prefix conversions, I want you to think about a whole big brother, little brother thing, right? I always try to give you something goofy to think about. Big, little, big, little, big, little. We're always going to have the bigger number going with the smaller unit. So look what we have here. Bigger number, millimeters are smaller than centimeters. So that 10 needs to go with the millimeters. Classic mistake that I see all the time is people have the right, whether it's 1 to 10, 1 to 100, 1 to 1,000, they have that right relationship, but they put the wrong number with the wrong unit, okay? So we have to make sure here, because we want millimeters cubed, this whole quantity has to be cubed. That's something that we've learned about already. And then we end up getting 0.5796958 centimeters cubed. So to finish out this problem, density is going to be equal to the mass, which they told us, 4.20 grams, divided by our volume in cubic centimeters there. So density is going to be equal to, let's see, 7.24518 grams per cubic centimeter. I'm going to go ahead and round to 3 significant figures here, looking back at my problem, right? These both have 3 significant figures here. So rounding to 3 significant figures gives me 7.25 grams per cubic centimeter. Always box your answer for me so I can make sure to quickly identify where the solution is in all of your work. Make sure that you have the correct number of significant digits, and make sure that you have the correct units. So that's problem 21.